Hello and welcome again. Thank you for tuning in to our weekly update. This week we're going to talk to you about two things. One, we're going to show you this is our putting together of our ground station, and the other one is the software aspect. So this is our ground station right here. This is our gear system. If you take a look over here, this is exactly what we kind of expected. We didn't expect this to work too well, but now you're starting to see the physical part of it's now becoming our virtual rover, and ground station is now becoming more physical. And another part that we want to show you is the wheel. This is functioning exactly the way we want it. You can see it's got some spring action, and right now we have this on the ground station. We won't be using this wheel on the ground station. We just wanted to see a proof of concept, and this is exactly this spring action that we need. So if you take a look, the wheel is made from these parts. This is our mold that we were talking about. We still need 8 more of these pieces, and then we require one more mold to put it all together. This was 3D printed, and this was made from our mold. And now, so this is coming together. Next week we'll be able to show you some more, and eventually we'd like to show it all in one big giant cube. And for the other portion of this update, we will go to a diagram, and it's a talk about our synchronization system that we're using for our devices, for our ground control to the ground station, like something like this, and the communication between the ground station with the communication module and then to the craft. So this is our mission control. This is our website here, and it will be talking with the ground station, and the way of communication is through the internet protocol. And the ground station will be talking with the main controller on the ground station. And it will be communicating through serial interface, and the main controller is talking with the communication module through the serial interface. That module will be communicating with the craft through a radio link, and the craft will be communicating with the communication module through the serial interface. So let's think of these spots here, these lines, as their own clock cycles. So we have 6 devices. The main controller on the ground control and the craft, they are clocks on the ground station, and the mission control, they have their own, each of these devices have their own clock, while the communication modules, they have timers that have a very good precision. And so if you see these cycles, these clock cycles, they're spread out, they're not synchronized. Normally you want a form of synchronization. So let's say this line here is when we decide to send out some information from our main control to our craft. So if you take a look at the red line, the main control here, there is this line here on the bottom. That's, let's say, that is that amount of time it took for the package to get ready to send to the ground station. This line here, this interval over time, is the amount of time that it takes for the mission control to communicate with the ground station, for the ground station to prepare its data to communicate with the ground station main controller to its communication module. And let's say this final, again, the communication module preps the data before it sends it out to the craft using our radio link. So here you see, this is the amount of time that it took to go to, this is the interval that it took to go to the craft. The package again is readied, interval to communicate with the craft, and then the cycle now returns, and each time these intervals will be different, right? So now it's returning back from the main controller to the ground controller. It takes an amount of time to get the packages ready. So this is until we go all the way back down to the mission control until the cycle is complete. So based off this cycle, what we can derive are we could get data, achieve data from here, from which we'll use for our synchronization without actually having the timers and the clocks synchronized. So you will see these lines. These are lines of time interval. So these are the set times. These are the different time intervals. This is the data that we're going to be using for each layer for each device. And what T delta is the start from the time mark to the ground station receiving the packet from mission control. TB is the time it takes to process the packet from the time that it received it from mission control. T up is the interval that it takes for the upper layers to run their communication. And TA is the interval that it takes to set up the packet for the communication between the ground station to mission control. T delta, TB, T upload, and TA on the upper layers, and it's the same concept. But if you take a look from all this data, we can derive TX and TY, and that is the interval that it takes to communicate between the devices. From there, for an example of what we can do with TX and TY, we could take that and we could derive that TX plus TY will equal to T upload minus TB plus T up plus TA of the higher level of the main control. So if you take a look, TX and TY, they're not equal intervals of time, but over running this cycle over and over again, we're able to find the average of TY and TX by taking TX plus TY and divided by 2. But over 100 packets, we'll be able to get the average of TX. Knowing the TX, we're able to get the correction, T correction, between the ground station and mission control. Now on to the more interesting part. Now we have TX and TY, so the same concept for the higher level. However, because the object is moving, so now we're communicating between the communication module from the ground station and communication module of the craft, the TX and TY will not be consistent. we will be able to derive them from the interval of all devices, and from that we could find the orbit of the aircraft. Sorry, not the aircraft, the spacecraft. So our communication modules are running at 16 megahertz. That's the frequency of the timer, and that gives us 40 meters precision of orbit calculations. So you got to see two of the things that we worked on this last week. Thank you for tuning in, and we will give you an update in 7 days.